Okie dokie. We're starting today our new unit. This is for those of you that were absent today. Um, we're using the Unit 4 dividing fractions packet. You should have received this from me a couple weeks ago before we had finished Unit 3. I just wanted to give it to you. So there's a like a cake or a pie or some dessert on the cover with fractions. Just make sure that you fill out the bottom here, put your name. I'm gonna just do it right now. So put your name down there. Base is Andromeda. Andromeda. And then the room would be, whatever you have your homeroom. So for my students, it would be 170, or the students in my room would be 170. But for everyone else, whatever room you're in. Okay. All right. So to start off this unit, we're actually going to be doing a little review. There's an idea here that is going to come back, and that idea is called greatest common factor, or GCF, an idea we've talked about before, but we're going to come back to it on the first day. So here's the vocab for Unit 4. You can see there's not very many words. You got greatest common factor, least common multiple, reciprocals. We'll get to all those during the unit. But again, this is if you missed class, you were absent the day we did GCF. So we're going to do a few of these together. You can try some on your own if you're getting it. But this is what you missed. So the first thing we're going to do some very basic GCF problems. And then we're going to look at some word problems. And we're going to use the same method that we used before when we looked at greatest common factor, and that's the factor trees. Okay? So to find the GCF of two numbers, for example, 8 and 32, we're going to write down 8, we're going to write down 32, and then we're going to break these numbers down. I'm just going to turn the lights on real quick. Here we go. Sorry for the delay. So we have 8 and 32 here. We're going to break these down by using factors of these numbers. So for example, what can I multiply by to get 8? Well, 4 times 2. And remember, the key thing here is that we're going to circle numbers we can't break down anymore. And we're never going to use the number 1. So I guess those would be the two big rules. We're going to circle numbers we can't break down anymore, and we can't use 1. So 2, you can't really break that down anymore. We don't want to do 2 times 1 because, again, we don't want any 1s. 4, on the other hand, we can break 4 down into 2 times 2. Now, both of those 2's we can circle. And one way to check to see if we're right, just multiply the numbers together. 2 times 2 is 4, times 2 is 8. We're only focused on the numbers we've circled. We're going to do the same thing for 32. Well, 8 times 4 is 32. If we think about 8, well, we can do 4 times 2 would get us to 8. 2 you can't break down, so I'm going to circle it's prime. It's called prime factorization. This is just another name for this. If the numbers are prime, you'd circle them. 2 and 2 we'd circle because you can't break them down. And then the 4 up here, we didn't do the 4 yet. We can break 4 down into 2 times 2 as well. And of course, we'd circle the 2's because we can't break them down. Now, at this point, we're checking to see what they have in common. Well, they have 2 in common, so I'm going to cross a 2 off. Make sure you cross them off because if you don't cross them off, you might get mixed up and forget that you've used that 2 already. So we have 2 in common. Oh, they have another 2 in common, so I'm going to cross a 2 off from each, times 2. And they have yet another 2 in common, times 2. Now, you might see they have a 4. Well, that 4 we didn't circle. So we're only paying close attention to the numbers we've circled. Those are the prime factors. And now that's it, because these 2's aren't in common because they're only in 32. There's nothing else they have in common. 2 times 2 is 4, times 2 is 8. So 8 is the GCF of 32 and 8. That means that's the greatest number I can divide them both by. 8 divided by 8 is 1. 32 divided by 8 is 4. That's the GCF. All right, let's try another one here. 24 and 60. Write down 24. We'll write down 60. Let's break them down. Now, if you want to try this one on your own, you can. If you want to break the numbers down differently from me, that's fine. You'll still get the same answer. 24. Let's do. I'm going to do 6 times 4. You can do 8 times 3 or 12 times 2, but I'm going to do 6 times 4, not 2. 6 times 4. All right. 6 is going to be 3 times 2. Circle the 3. Circle the 2. 4 is going to be 2 times 2. Circle the 2. Circle the 2. So again, we only circle the numbers we can't break down. Those are the prime, what are called the prime factors. 60. Would be 10 and 6. Well, let's break down 10. We can break down 10 into 5 and 2. We can circle both because you can't break down 5 anymore. You can't break down 2. And then the 6 would be 3 times 2, and we'd circle both. And now what we're doing, of course, again, we're looking at what do they have in common. They have a 3. They have a 3 in common, 3. And they have a 2 in common, a 2. And they actually have another 2 in common, another 2. The reason I'm saying a 2 is that even though we're crossing 2 off, they have 1 2 in common, another 2 in common, and 1 3 in common. All right? So we wound up having a 3 and a 2 and a 2 in common. 3 times 2 is 6. Times 2 is 12. So that is going to be the GCF. Oh boy. That is going to be the GCF of 24 and 60. 12 is the greatest number you can divide 24 and 60 by. It's also the greatest number you can use to get to 24. 12 times 2 is 24. 12 times 5 is 60. All right. Now, you may notice in these problems below here that there are 3 numbers. And believe it or not, we're going to try these in the same way we tried the ones before. We're going to break them down, each number, and then we'll see what they all have in common. So 12, 18, and 26. We're going to see what they all have in common across the 3 numbers. So same steps here. 12 you can break down into, 2 times 6. Well, we'd circle the 2 because you can't break it down. 6 would be 3 times 2. Circle the 3, circle the 2. Nice. Okay. So let's move on to 18. 18 might do 6 times 3 or even 9 times 2. I'm going to try 9 times 2. Now 9 you can break down into 3 times 3. 3 is prime and 3 is prime, so we circle those. What are you looking for? Sorry, I just had a special guest. This 2 here, we can circle it because you can't break that 2 down. But now we're moving on to 26. Well, 26 is a little tricky. So 26, 2 is definitely a factor because it's even. And 2, I believe, would be 13. 2 times 13. Can't do anything with 13. No way. And you can't do anything with 2. No way. All right? So now we're looking at what do they have in common in all 3 numbers. Well, all 3 numbers have a 2. There's a 2 here, there's a 2 here, there's a 2 here. Let's see. I see a 3, but there's no 3 in 26. I know there's a 13, but there's no 3. So 3 wouldn't work, and 26 is the only number with 13. So that's it. It has to be in all 3 numbers. So we only have a 2 in common for all 3 numbers. So 2 is the GCF. That's the greatest common factor. It's the greatest number you can divide all 3 of these numbers by, believe it or not. Believe it or not. All right, if you want to try this one on your own, go for it. You can pause the video, try it. But 20, 28, and 12, we're going to do the same thing here. Same thing. We're going to set this up. We're going to break down each number into its prime factors, circle the numbers you can't break down, and then at the end we're going to compare to see what they all have in common. I'm just going to move this down slightly. There we go. 20. Maybe we'll do 5 times 4, of course. Okay, 5 times 4. Can't do anything with the 5. Can't do anything with the 5, so we're going to circle that, but we can break down the 4 into 2 times 2. I had 2 on my mind there. So 2s you can circle. Check. Well, let's just check real quick to make sure we got it. 2 times 2 is 4, times 5 is 20. So that checks out. 28. Break that down into 7 times 4. Circle the 7. Break the 4 down into a 2 times 2. Booyah. Booyah. And 12, you can do 4 times 3. 4, of course, would be 2. Anytime you see 4, you can break that down into 2 times 2. 3 would just be 3. All right, so now we're looking to see what they all have in common. Well, they all have a 2. All of them have a 2, so I'm going to cross the 2 off. And they also have another 2. All of them have another 2, so I'm going to cross those 2's off. And 2 times 2 is 4. So 4 is the GCF. 5, 7, and 3, they didn't have in common, so that was it. It was just the 2 and the 2, which would be 4. Okie dokie. Now, we're going to do a couple word problems here. We're going to see if there's anything these have in common, these word problems. It says there are 1 slice servings of 3 types of cake on a table. Each row has an equal number of cake servings and only 1 type of cake. So they don't mix up the flavors, only 1 type of cake in each row. What is the greatest number of servings in each row? I'm going to highlight that. Greatest number of servings in each row. All right. That tells me we're going to find the greatest common factor. The greatest common factor will tell you the greatest amount per row that you can put in each row. Okay? So we're going to find that we're going to use GCF, the method we just worked on, prime factorization. We're going to find that GCF to answer this question. So 10, 15, and 20. These numbers might be pretty easy to work with here, I hope. So 10 is going to be 5 times 2. You can circle both of them. You can't do anything with 5 or 2. 15 would be 5 times 3. Again, nothing else to do there. You can't break the 5 down. You can't break the 3 down. We're done. 20 would be, well, 5 times 4. The 5, you circle the 5. And 4 would be 2 times 2. And now we check. We see what they all have in common. They all have to have this number in common. They all have a 5. You can see it there. They all have a 5. That is the only number they all have. So what is the greatest number of servings in each row? So we'd say the greatest number of servings in each row is 5. Okay, so if you need to pause it to write that down, you can pause it and write that down, but that's going to be the GCF of those numbers. So you can put 5 marble in a row, 5 red velvet in each row, and 5 chocolate. So there'd be like 2 rows of marble, 3 rows of red velvet, 4 rows of chocolate, because you're going to put 5 in each row. That sounds delicious. That sounds delicious. All right, so we're going to go to the next page. We're going to try out some word problems here. We're going to see what they have in common. It says Lana earned $49 on Friday, $42 on Saturday, and $21 on Sunday selling bracelets. She sold each bracelet for the same amount. What is the most she could have charged for each bracelet? So the most for each bracelet. That reminds me of the cake problem. The cake asks us, what is the greatest number per row? This is asking, what is the most per bracelet? Okay, so that again indicates that it's going to be a GCF problem. So let's set it up. We got these amounts. We're trying to see what is the greatest amount she could charge if this is how much she sold. Let's break them down. Let's do it. 21. Let's start with 21. That's an easy one. You got to do 7 times 3, and that's it. 7 and 3. 7 and 3. 42. You could do 7 times 6. 7 times 6. Circle the 7. You could break down the 6 into 3 times 2. Now, this is when you need to know your math facts. 49 is 7 times 7. And then once you do that, it becomes apparent or clear that the number they all have in common, the only one, is 7. So what is the most she could have charged for each bracelet? So $7 is the most she can charge per bracelet. All right, so that's a good one. That's a good one. That's going to use GCF to find the answer. All right, here we go. Here we go. If you need to pause it to copy this down, feel free to pause it. All right. 45 boys and 30 girls divided into groups. Okay. Find the greatest number of groups that can be created if no one is left out. So again, greatest number of groups reminds me of the cake. That was greatest number of pieces per row. Also reminds me of the most Lana could charge. Greatest number of groups that could be created. Okay, so we got 45 boys and 30 girls. We're going to find the GCF. We're going to find the greatest number of groups using the GCF. So 45 boys, 30 girls. Let's break them down. 45 would be, you could do 9 times 5. Circle the 5. Break down the 9 into 3 times 3. Okay. 30. Let's talk about 30. 30, you can do 6 times 5. Circle the 5. Break the 6 down into 3 times 2. Circle the 3, circle the 2. All right, at this point, we're looking to see what they have in common. Oh, they have a 5 in common. Cross the 5 out. They've got the 5 in common. And they also have a 3. 1 3 in common. 5 times 3 equals 15. So the greatest number of groups that you can make 15 groups. So there'd be 3 boys and 2 girls in each group. That is the greatest number of groups you can make. The greatest number of groups is 15. Nice, nice.